Question 2 requires us to perform unit conversions on a number of the variables we've been given. We've been given 3 of the variables in the question: the length, 1.9 metres, represented by L, the load, 80 kilonewtons per metre, represented by W, and the modulus of elasticity, 205,000 newtons per millimetre squared, represented by E. In the first part of the question, we have already obtained a further value from our data tables. The second moment of area about the x-axis, I subscript xx, which is 205,282 centimetres to the power 4. We've been asked in the question to find the maximum deflection in millimetres. Therefore, all length units must be converted to millimetres. And secondary to that, all of our force units must be converted to units which are consistent. So either all must be in newtons or all must be in kilonewtons. In this question, we're going to convert everything to newtons, but it would be equally correct if you convert them all to kilonewtons and perform the calculation this way. But you'll see why shortly, why newtons makes it for an easier calculation. First, let's start with length. Length is 1.9 metres, and it should be quite a simple conversion to see that we're going to multiply by 1,000, because that's 1,000 millimetres from 1 metre. The metres cancel on the top and the bottom of the conversion factor to give us 1,900 millimetres. Our next unit is the second moment of area, and this has been given in centimetres to the power 4. Again, we need to convert to millimetres, but we have to remember that this is the power 4. Our conversion factor should also be raised to the power 4. So it's a conversion factor of 10 millimetres and 1 centimetre, but that raised to the power 4 is going to be a multiple of 10,000. When the centimetres to the power 4 will cancel, top and bottom, leaving us with millimetres to the power 4 as our units, as we require, and multiplying that number by 10,000 gives us this rather large number here. 205,282 and 4 zeros at the end because we've multiplied by 10,000. Load is given 80 kilonewtons per metre, and this is where you will see why converting to newtons is going to be helpful in this type of question. To convert kilonewtons to newtons, we'll be multiplying by a factor of 1,000 here to get kilonewtons in the bottom, so we can perform our cancellation of units, giving us a factor of 1,000. And to convert metres to millimetres on the bottom of our units, we'll be dividing by 1,000 to get millimetres in the bottom and metres cancelling top and bottom. As you can see here, we have units of newtons per millimetre, but the 1,000 multiple and the 1,000 division are going to cancel, leaving us with 80 newtons per millimetre. And in the question, it's okay to write that down as long as you know what you're doing with the units. If you have to convert from kilonewtons per metre to newtons per millimetre, the conversion factor is 1, and you can just change the units. That leaves us with the modulus of elasticity, and as you can see here, the force is already in newtons, and the length is already in millimetres. Another reason for working in newtons here. No conversion is required. We only need to use this value in our calculation.